Good morning everybody. Welcome back to our channel Sri Education. So ninth class, today topic is ninth class. In previous class we learned the parallelogram, properties of parallelogram. Today class here exercise 8.3 ninth class. First question. The opposite angles of a parallelogram are 3x minus 2 degrees and x plus 48 degrees. Find the measure of each angle of the parallelogram. So here opposite angles are given in a parallelogram. We find the four angles. So here I am already draw the parallelogram. Here opposite angles of a parallelogram are 3x minus 2 degrees and x plus 48. Here 3x minus 2 degrees and opposite angle is x plus 48. In parallelogram opposite angles are equal. So these two are equal. So now we write the given that the opposite angles of parallelogram are, here opposite angles are, first one is 3x minus 2 degrees and x plus 48 degrees. So these two are equal. These two are equal means we write here, thus here 3x minus 2 is equal to here x plus 48. These two are equal because here opposite angles of a parallelogram are equal. Opposite angles of a parallelogram are equal. So these two angles are equal. We write the x terms in left side. Here 3x minus x, 3x minus x equal to 48 plus 2. So here 2x equal to 50, x equal to 50 by 2, that equal to 25 degrees, x equal to 25 degrees. So here we write the these two angles. Here angles are here the given angles, therefore the given angles given angles are, here first one is 3x minus 2. Here substitute the x value. Here 3 into 25 minus 7 minus 2 equal to here 75 minus 2. 75 minus 2 is equal to 73 degrees. Next second one is the here x plus 48. X plus 48 means here x plus we write 25 plus 48. 25 plus 48 is equal to 73 degrees. So these two are equal. Opposite angles are equal. So in we find the another two angles. These two are the opposite means these two are equal. So in parallelogram consequent angles are supplementary. Suppose here angle A and B are consequent angles. These two are supplementary. So here we write that one. Here this is 73 degrees. 73 degrees plus B equal to here 180. So here we write the we know that the consequent angles are supplementary in parallelogram. Supplementary in parallelogram. So here consequent angles are here the other two consequent angles. So here one is the angle A plus angle B equal to 180 degrees. So here already we know that angle A equal to 73 degrees plus angle B equal to 180. Angle B equal to 180 minus 73. Here angle B equal to 107 degrees. So this is the another angle of B. So now here we write the four angles. Here angle B equal to angle D. Here angle B equal to angle D equal to 107 because opposite angles are equal. Angles are equal. So here these two angles are equal. So here we write the four angles. Therefore the four angles are 73 degrees and 107 degrees, 73 degrees and 107 degrees. These are the four angles in a parallelogram. This is the complete solution of first one. Next, second question, find the measure of all the angles of parallelogram if one angle is 24 degrees less than the twice of the smallest angle. So here find the measure of the angles parallelogram if one angle is less than the twice of the smallest angle. So here less than twice of the smallest angle, 24 less than twice of the smallest angle. Here relation is given in angles. So we find the four angles. So here first let the smallest angle we take x. So here let the smallest angle, here we take x. So next here another consequent to angle, then it's consequent to angle, then it consequent to angle is equal to, here consequent to angles sum is equal to 180. So we take 180 minus x. Sum is equal to 180 means here another angle is 180 minus x. So here by problem, here 24 less than the twice of the smallest angle. So we write that relation. Here by problem, here 180 minus x, here 24 less than smallest angle. If is 24 less than the twice of the smallest angle. So here smallest angle is x. So we write here twice of the smallest angle is less than 24. 180 minus x equal to 2x minus 24. So we write this one, simplify and find the x value. So here 180, 24 carry to left hand side. Here 24 is equal to 2x plus x. Here 180 plus 24, 204 equal to 3x. Here x equal to 204 by 3. 204 by 3. Here 3 ones are 3, 6 are 18. Here 2 is there, 2 4 24. 24. Here 3 8s are 24. 680 degrees. So here x equal to 68 degrees means we write the angles. Here the angles are, one is the x means here first one is we write 68 degrees. Next one is the 180 minus x. Here we write 180 minus x. 180 minus x equal to, here we write second angle is 180 minus x. Here 180 minus x equal to x place we write the 68. Here first angle, second angle. Here second angle equal 180 minus x. Here 180 minus 68 is equal to 112 degrees. Here two angles are 68 and 112. We write the four angles. So now here the angles are (68 degrees, 112 degrees), next 68 degrees, 112 degrees. These are the four angles in a parallelogram. This is the complete second one answer. Next, third question, in the adjacent figure ABCD is a parallelogram and E is the midpoint of the side BC. So ABCD is a parallelogram and E is the midpoint of BC. These two sides are equal. If DE and AB are produced to meet at F, show that AF equal to 2AB, AF equal to 2AB. We show this one. So now here A, see midpoint is the E. So here we mark the midpoint of AD. Here G. So here we mark the point GD in A, midpoint of AD. G is a midpoint of AD. So here E is a midpoint of B, C. B to E equal to E to C. Now here join the G, C. Here join G and C. Here first we write the given data. Here given that a parallelogram ABCD is a parallelogram. ABCD is a parallelogram. Here E is the midpoint of BC. Here E is the midpoint of the side BC. We write that one. E is the midpoint of BC. So let G be the we draw G be the midpoint of AD. So let G be the midpoint of AD. So join G comma E. Join G comma E. So now here we take the triangle AFD. We take the triangle AFD. Now in triangle AFD, here GE is the line joining of the midpoint. Here GE is the line joining of the midpoint. Line joining of the midpoint. So here joining of the midpoints G comma E. G comma E of two sides of AD and FD. AD and FD. So here GE is the line joining midpoints of AD and DF. So here therefore GE is parallel to AF. GE is parallel to AF. Next here and GE equal to here GE equal to half of AF. GE equal to half of AF because here GE is the line joining of the midpoint of G comma E of two sides of AD and AF. So we write this one. Now here but here GE equal to, already we know that GE equal to AB because here ABCD is a parallelogram. So this is the midpoints of the other two sides. So these two are the parallel. GE and AB are the parallel lines. So parallel lines means these two are the equal. GE equal to AB. So here ABEG is a parallelogram and ABGE forms a pair of opposite sides. Forms a pair of opposite sides. Opposite sides. So here forms a pair of opposite sides. So here we write 1 by 2 AF. 1 by 2 AF equal to AB. Here GE equal to, we write AB. GE equal to AB. 1 by 2 AF equal to AB. So that implies we write here these two carry to right hand side. So here AF equal to 2 AB. 2 AB. So here you are asking AF equal to 2 AB. So hence proof. This is the proof of third question. Next, fourth question. In the adjacent figure, ABCD is a parallelogram P comma Q are the midpoints of the sides AB and DC respectively. Show that PBCQ is also a parallelogram. So here ABCD is a parallelogram. P and Q are the midpoints of the sides AB and DC. So here respectively, then show that PBCQ is a parallelogram. We show that this is the parallelogram. First join these two points P and Q. Here already draw the parallelogram ABCD. Here P and Q are the midpoint of AB and DC. So here join the PQ. Join PQ. So now here we show that PBCQ is a parallelogram. So here first we write the ABCD is a parallelogram. We write here ABCD is a parallelogram. So here P comma Q are the midpoints of the side AB and DC. P comma Q are the midpoints of AB and CD. So next here join Q comma P. Here join Q comma P. Now here we write now AB equal to CD. AB equal to CD because these two are the opposite sides of a parallelogram. These two are the opposite sides of a parallelogram. These two are equal. So here both sides here divided with 2. So here 1 by 2 into AB is equal to 1 by 2 into CD. Both sides divided with 2. So here we write 1 by 2 AB, 1 by 2 AB, 1 by 2 AB. These two are equal midpoints. These two are equal, because here P and Q are the midpoints. So we write here 1 by 2 AB equal to here PB. We write PB. Next PB, here 1 by 2 CD. 1 by 2 CD equal to, we write QC. PB equal to QC. Next here AB and DC are the parallel sides. So AB and DC are parallel means here PB and QC also parallel lines, and also PB is parallel to QC. These two are the parallel line. So now here we write here, now in parallelogram we write PBCQ. Here PBCQ. These two are parallel sides, and PB and QC are equal. So here in this PBCQ, here PB equal to QC, and PB is parallel to QC. So now here this is the parallelogram. So here therefore hence PBQC is a parallelogram, or CQ. Here CQ is given, CQ is a parallelogram. PBCQ is a parallelogram. So here hence proved. This is the complete proof of fourth question. Fifth question, ABCD is an isosceles triangle. ABC is an isosceles triangle which AB equal to AC, and AD bisect exterior angles of QAC. AD bisect exterior angle of QAC. Bisect means these two angles are equal. So next here CD is parallel to BA. CD is parallel to BA. These two are parallel lines. These two are parallel. So now here, as shown in the figure, show that angle DAC is equal to BCA. These two angles equal. We show that these two angles are equal, and ABCD is a parallelogram. In this question, ABC is a isosceles triangle in which AB equal to AC. AB equal to AC. These two sides are equal means these two sides opposite, equal sides opposite angles also equal. These two angles are equal. So next here AD bisect exterior angle of QAC means these two angles are equal. These two angles are equal, and CD is parallel to BA. CD is parallel to BA. So as shown in the figure, show that angle DAC equal to BCA. DAC, this angle, these two are equal. This angle DAC equal to BCA. These two angles are equal. We show that these two angles are equal. First here we write the given data. Here given that triangle ABC is an isosceles triangle. Is it isosceles triangle AB equal to AC. These two are equal. So next here AD is bisect. Here AD bisect exterior angle of QAC. So here AD is bisector of QAC. Now next here we prove that first one angle DAC equal to angle BCA. Angle DAC equal to angle BCA. So here first these AB and AC are the equal sides. So these two angles, opposite angles are equal. So we write that one. First in triangle ABC, we take triangle ABC. AB equal to AC is a isosceles triangle. AB equal to AC. So here these two sides opposite angles. These two sides opposite angles are, so here opposite angles are angle B equal to angle BCA. So we write that one. Here angle in triangle ABC, here AB equal to AC means that implies here angle B equal to angle here ACB. These two angles are equal. We write ACB. We write any one, both are same. Angle ACB. Here these two are equal because this is the opposite sides of a equal sides. Angles opposite to equal sides. equal sides. These two are equal. So these two are equal means already we know that here also here QAC. QAC is a exterior angle of triangle ABC. QAC is a exterior angle of triangle ABC. So this exterior angle equal to sum of opposite interior angles. So here we write that one. QAC equal to sum of opposite interior angles. That two interior angles are BCA plus here angle B. BCA plus angle B. These two angles. So here we write B angle B equal to angle BCA. These two are equal. So we write that one. Here angle already we know that angle B equal to BCA or ACB. Both are same. So here ACB. We write that one. Here angle here this one equal to here angle BCA plus here we write BCA equal to B equal to BCA. These two are equal. So now here we write angle QAC equal to 2 into angle BCA. So now here both sides divided with 2. Both sides divided with 2. Divided with 2. So here 1 by 2 angle QAC is equal to here 1 by 2 to angle BCA. So these two are get cancelled. Here 1 by 2 QAC. 1 by 2 QAC. 1 by 2 QAC means here AD is a bisector. So here DAC. We write here DAC. So here QAC equal to angle DAC. That equal to here angle BCA. So here because here AD is a bisector of QAC. So this is the first proof. Now here we prove that second one ABCD is a parallelogram. So we write here ABCD is a parallelogram. First here already we know that DAC equal to BCA. DAC equal to BCA. So these two angles are equal. But these two from the pairs of the alternate interior angle of a parallelogram. These two angles are equal means AD and BC are parallel lines. So we write that one. Here first, second one from one is equal to DAC equal to angle BCA. So this one equal to here these two are these forms a pair of alternate interior angles of a pair of parallel lines. Angles for the pair of lines AD and BC. AD and BC. So here AC is a transversal. AC is a transversal. AD and BC are a parallel lines. AC is a transversal lines. These two angles equal means. So here therefore AD is parallel to BC. So in ABCD, AB is parallel to DC and BC is parallel to AD. So therefore ABCD is a parallelogram. So this is the fifth proof. So this is the complete solution of fifth one. Next, sixth question. ABCD is a parallelogram. AP and CQ are perpendiculars drawn from vertices A and C, diagonals on diagonals BD. So show that triangle APB is congruent to triangle CQD. So here AP equal to CQ. ABCD is a parallelogram. AP and CQ are perpendiculars drawn to the vertices A to C. A to C, these two are the perpendicular, AP and QC. So on diagonal BD. So BD diagonal in triangle APB is congruent to CQD. These two triangles are congruent. We show that. And AP equal to CQ. A P equal to CQ. Automatically first these two are congruent, automatically AP equal to QC are corresponding parts. So first we show that first one. Here ABCD is a parallelogram. First we write the given data. ABCD is a parallelogram. Given that ABCD is a parallelogram. So next BD diagonal. BD is a diagonal and drawn from the vertices A and C on the diagonals BD show that. So perpendicular drawn from the vertices AC on the diagonal BD. So here BD is a diagonal. So next AP is perpendicular to BD and CQ is perpendicular to BD. So here AP is perpendicular to BD and CQ is perpendicular to BD. These two are the perpendicular. First we prove that these two triangles are congruent. So here APB and CQD, these two triangles are congruent. We prove that. So first one, here we take these two triangles. In triangle APB and triangle CQD, we take these two triangles and compare the sides. So here AB equal to DC, because ABCD is a parallelogram, opposite sides of the parallelogram. AB equal to CD, here opposite sides of the parallelogram. So next here angle, here APB, next CQD, both are 90 degrees. APB equal to angle CQP equal to 90 degrees. So here both are 90 degrees. Now next here angle, here this angle and this angle, these two are equal. Here first AB and DC are the parallel sides of the parallelogram. So these two angles are equal. We write that one. Here angle PBA is equal to here angle QDC. These two are the alternate interior angles of the lines. Angles for the lines AB and DC. These two are the alternate interior angle for the lines AB and DC. So here these two sides are equal, two pairs of angles equal. So these two triangles are congruent. Triangle APB is congruent to triangle CQD. So by AAS congruence, AAS congruence, these two triangles are congruent. This is the first one proof. So these two triangles are congruent means we compare the AP equal to QC, because these two are the corresponding parts of a congruent triangle. So we write second one answer easily. Here first from 1 here triangle APB is congruent to triangle CQD. These two are equal because here AP equal to CQ, corresponding parts of a congruent triangles. So these two are the equal. This is the complete solution of sixth one. Now seventh question, in triangle ABC and DEF, ABC and DEF, AB is parallel to DE, AB is parallel to DE. These two are the parallel sides. So next BC equal to EF, BC equal to EF. These two sides are equal. So next BC is parallel to EF, BC is parallel to EF. These two are the parallel sides. Vertices ABCD, join the two vertex DEF. So join these lines already here given. So respectively show that ABCD is a parallelogram, BCEF is a parallelogram, AC equal to BF, triangle ABC is congruent to triangle DEF. First we prove that ABED is a parallelogram, ABED, this is the parallelogram. These two are the parallel sides, and here BC equal to EF. So these two are the parallelogram. Here first we prove that first one ABEF ABED is a parallelogram. Here first we write the given data. Here given that in triangle ABC and triangle DEF, these two triangles, here AB is parallel to DE. Here AB equal to DE and AB is parallel to DE. AB is parallel to DE. So next one, here BC equal to EF and BC is parallel to EF. These two are the parallel sides. First here ABED is a parallelogram. ABED. So these two are parallel lines and AB equal to ED. So ABCD is a parallelogram. We write that one. Here first in ABED, here AB is parallel to ED. AB is parallel to ED or DE and AB equal to ED. So here therefore here hence ABED is a parallelogram. So here second one in BCED. So here BCEF. Here BCEF. We take BCEF. BCEF. So here BC is equal to EF and BC is parallel to EF. So these two are equal and parallel. So hence here BCEF is a parallelogram. Here BCEF, these two are equal and parallel. So is a parallelogram. Next we prove the third one. Here third one is the, here we write the third one. Third one is ACFD is a, here AC equal to DF. AC equal to DF. Here AC equal to DF. Here ACDF is a parallelogram because in the opposite sides are equal. Opposite sides are equal. So here ACFD is a parallelogram. So in a parallelogram, opposite sides are equal. So yes, so AC equal to DF. AC equal to DF. Next fourth one. Consider triangle ABC is congruent to triangle DEF. DEF. So here these two ABC and DEF, these two triangles. Here these two are the parallel sides and equal. These two are parallel and equal. So here AB equal to DE. AB equal to DE. This is the given. So next here AC equal to DF. This is also here AC equal to DF, third one already proved. Third one proved. So next here BC equal to EF. EF here given. Here BC equal to EF given. So now here therefore triangle ABC is congruent to triangle DEF. These two are the equal. By here three sides are equal. ACS congruency. These two are the equal. These two triangles are the equal. So this is the seventh one proof. So this is the seventh one complete solution. Next eighth question. ABCD is a parallelogram. AC and BD are the diagonals intersect at O. P and Q are the points of the trisection of the diagonal BD. P and Q points are trisection of this diagonal. So DQ equal to QP equal to PB. So here proof that CQ CQ is parallel to AB. CQ is parallel to AB. And also AC bisect PQ. AC is bisect PQ. Here ABCD is a parallelogram. AC and PD are the diagonals. So first we write the given data. Here given ABCD is a parallelogram. So here BD is a diagonal. So here P comma Q are the points of the trisection of the diagonal BD. Diagonal BD, here trisection of these 2 points. Here DQ equal to QP equal to QB. So here P comma Q are the points of trisection of BD diagonal. So here DQ equal to QP equal to PB. So here dissection means these 3 lengths are equal. So now here we take in triangle APB and triangle CQD. Compare these 2 triangles. So here APB, this triangle. So here this triangle, and CQD, this triangle. These 2 triangles. We compare these 2 triangles. AC equal to DC, because these 2 are the parallel sides of a opposite sides of a parallelogram. These 2 are equal. Next, DQ equal to PQ in given question. DQ equal to PQ. So next here angle DCDQ, this angle equal to here this angle, because DC and AB are the parallel sides. So here DB is a transversal. So these 2 are the alternate interior angles. These 2 are equal. So now these 2 triangles are congruent. So we write that one. So here in triangle APB and triangle CQD, these 2 triangles, here AB equal to CD, AB equal to CD, opposite sides of a parallelogram ABCD. So these 2 are equal. Next, BP equal to CQ. This is the given in the question. Next, here angle ABP equal to angle CDQ. These 2 are equal. So here since alternate interior angles for the lines AB is parallel to DC and BD as a transversal. So these 2 are. So here 2 sides are equal and 1 angle is equal. Means these 2 are the congruent. So here therefore triangle APB is congruent to triangle CQD. These 2 triangles are congruent. So next similarly we take same as we take DAQ and CPB. These 2 triangles. We take these 2 triangles and compare. So similarly in triangle AQD and triangle CPB, these 2 triangles. So here compare these 2 triangles. Now here in triangle AQD, this triangle, this triangle. So next CPB, this triangle. We compare these 2 triangles. So here first DQ, here AD equal to BC. These 2 are the opposite sides of a parallelogram. So these 2 sides are equal. Next DQ equal to PQ. Already we know that this is the given in question. So here this one. So next here angle ADQ equal to here PBC. These 2 angles are equal because these 2 are the DC and AB are the parallel sides. BD is a transversal. So alternate interior angles. These 2 angles are equal. Here two sides and one angle is equal. So these two triangles are congruent. We write that one. So here AD equal to BC, opposite sides of a parallelogram ABCD. So these two are equal. So next DQ equal to PB. This is the given in the question. So next one here angle ADQ is equal to angle CBP. So alternate interior angles for the parallelogram. So here lines AD is parallel to BC and BD as a transversal. So these two are the equal. So therefore angle AQD is congruent to triangle CPB. These two are the congruent. So now here in APCQ is a quadrilateral. So this one we prove that is a parallelogram. APCQ is a parallelogram. So here first APCQ is a parallelogram. We prove that one. So here AQ equal to CP. These two triangles are congruent. So these two are the corresponding sides. These two are equal. Same here QC equal to QP. These two are the congruent triangles. So QC equal to AP, corresponding parts of a congruent triangle. So these two are equal and parallel. So APCQ is a parallelogram. So next CQ is parallel AP. CQ is parallel to AP. So these two are the parallel sides. Now AC is bisect PQ. AC is bisect PQ because here these two are the diagonals of a APCQ parallelogram. But in parallelogram diagonals are bisect each other. So these two are the AC is bisect to PQ. So here proof is here asking AC is bisect PQ. So first one is here we write that one. So here AP equal to CQ, corresponding parts of a congruent triangles of a triangle APB and triangle CQD. So here this is the first one. Next AQ equal to CP. So this is also corresponding parts of a congruent triangle, triangle AQD and triangle CPB. So here therefore APCQ is a parallelogram. So here therefore CQ is parallel to AP, opposite sides of a parallelogram APCQ. So here also AC bisect PQ. So diagonals of A parallelogram APCQ. Diagonals of parallelogram APCQ. So hence proved. This is the complete. Now here eighth one solution is completed. So this is the 8th question and solution. Here first half and next half is this one. So here completed. Next 9th question, ABCD is a square. EFG and H are the midpoints of AB and BC, CD, DA respectively, such that AC equal to BF equal to CG, DH. Prove that EFGH is a square. So here ABCD is a square. Midpoints EFGS. So these midpoints join these midpoints. Here that diagram is a square. We prove that that one is a EFGH is a square. So here I am already draw the diagram. So ABCD is a square. ABCD is a square means four sides are equal. So EFGH are the midpoints. EFGH are the midpoints of these four sides. Midpoints of four sides. So DA respectively such that AE equal to BF, AE equal to BF equal to CG equal to DH. These four sides are equal. prove that EFGH is a square. So means here, suppose here AE equal to BF, AE equal to BF, BF, these two are equal. Next, CG equal to DH. These four sides, four lengths are equal means A to E, B to F, C to G, D to G means here this is the midpoint means these two are also equal. So these four sides also, these four lengths also equal. A to E, E to B also equal. E to F, F to C also equal. So now here we prove that EFGH is a square. This mid one is a square. So here first we write the as usual given data. So here given that here first ABCD is a square. ABCD is a square. So here ABCD is a square means EFGH, EFGH are the midpoint of these four sides. Midpoint of are the midpoints of AB, BC, CD and DA. So these four sides midpoint. So now here also here AE equal to BF, AE equal to BF equal to CG equal to DH. So now here we prove that EFGH is a square. We prove that EFGH is a square. So here we prove that this one is square. Before first we take the triangle ABC. We take this half triangle. So here we take this half triangle and we take this half triangle. So we take this half triangle and here AC midpoint is F, AB midpoint is E. So here join EF. Here already join EF. So this is the triangle. So now here midpoint of the sides AB and BC, EF are the midpoints. So now here EF equal to half of AC. EF is equal to half of AC. We write that one. So here we write that one in triangle ABC. In triangle ABC. So here ABC, EF are the midpoints of sides AB and BC. So are the midpoints of the sides AB and BC. So here EF is parallel to AC and EF equal to 1 by 2 AC. This is the equation 1. So now here next we take the another triangle. Here this one, we take this triangle. Here ACD. Here H and G are the midpoint of these two sides AD and DC. So here same here GH equal to half of AC. So we write similarly we take this triangle and write the GH equal to half AC. Here similarly GH is parallel to AC and GH is equal to, here GH is equal to 1 by 2 AC. So this is the equation 2. So same here we take the now this triangle and this triangle, these two triangles also. We write similarly here GF is parallel to BD and GF equal to 1 by 2 BD. This is the equation 3. Next here HE is parallel to BD and HE equal to 1 by 2 BD. So this is the equation 4. These two are the diagonal, same diagonals. This is also one diagonal. So here now but diagonals of the square AC and BD. Here in a square diagonals are equal. So but here AC equal to BD. These two are the diagonals of a square. So here therefore EF equal to FG equal to GH equal to HE. Here EF equal to, these two are equal means here these four are the equal. AC equal to BD means here half of GH. So here four lengths are equal. EF equal GH equal to FG equal to GH equal to HE. So here four sides are equal means here these four sides are equal means EFGH is a rhombus. So here hence EFGH is a rhombus. So here rhombus. This is rhombus means here diagonals are perpendicular each other. Also in diagonals of a rhombus perpendicular to each other. So these two are the diagonals of a rhombus. These two are the diagonals of a rhombus. Therefore, in the parallelogram OIEJ, here OI is parallel to EJ and IE is parallel to OJ. So here OIEJ, we take OIEJ. So in a parallelogram OIEJ, here these two are the parallel sides and these two are the parallel. So these opposite sides are parallel means here we write the, here we have angle IOJ. IOJ is equal to angle E. IOJ, opposite angles. These two are opposite angles. So these two are opposite angles and sides are equal. So here he equal to 90 degrees because EFGH is a square. Square means here each angle is 90 degrees. E equal to 90 means here O is also 90. These two are the opposite angles. So here we have IOJ equal to angle E. These two are the opposite angles of a parallelogram. Opposite angles of a parallelogram means here angle E equal to 90 degrees. Therefore, angle equal to 90 degrees. So here hence in a quadrilateral EFGH all sides are equal. So and one angle is 90 degrees. One angle is 90 degrees. So therefore EFGH is a square. EFGH is a square. So this is the complete proof. This is the 9th solution, first half. So here next. So this is the last problem of this exercise 8.2. This complete notes PDF link on description is there. If you are interested, download it.